Hello, this video will cover section 5.1, simple interest and discount. And this is for the class Math 1324. So this is the first video, and I will try to keep it about a 13-minute long video so I can upload it from my iPad. So the topic here, the main topic is simple interest. And in fact, the whole chapter 5, it talks about finance. And we're going to be discussing first simple interest. Then in section 5.2, it will be compound or compounded interest. We could compare simple interest to a linear function. And this is because every year you start with certain amount. So if you remember that mx plus b, this could be like the amount you start investing. And then after that, you will be earning interest. And, it depends how many years. So the formula, the first one that we're going to discuss, it just shows us how the interest will grow in simple interest investment. So we're going to use capital I to denote interest and PV to denote the present value. We will have R for rate, and we will have T for years. And it is important that we always keep it in years, because sometimes the problem will be telling us something in months, like the one that we have here, 9 months. And so because of that, we're going to have to use a fraction, but we'll get to that in a minute. So for this problem, it's about a personal loan, and it was taken to furnish a new apartment. So Maggie borrowed $4,000 at 3% interest from her parents for 9 months. How much interest will she pay? So here the question is, how much will the interest be? Now, what we know is the present value, what she borrowed. Sometimes this is called the principal, and some books only use the capital P to denote the principal or present value. So that will be what she borrowed, $4,000. The rate, it is 3%. However, we have to convert it to a decimal before we use it in any of this formula. So to do that, to drop the percent symbol, we need to divide by 100. So that means that we move the decimal point 2 units to the left, 1, 2. So we have to put a 0 there to fill in the space. And so we'll be using 0.03. Another thing that we know is that the time is 9 months. So because a year has 12 months, we use 9 divided by 12. So now we're going to use the formula that was given to us here. And so that says the interest equals the present value multiplied by the rate multiplied by the time. So we're going to substitute the numbers that we know, 4,000 for the present value, 0.03 for the rate, and for the time we will enter 9/12. Now we could enter all of this at once, but make sure that when you enter your fraction 9/12, you still keep that in parentheses so the calculator understands what you are asking. So after entering those numbers, well, also you could consider the time to reduce the fraction to enter something like both numbers are divisible by 3. 9 divided by 3 is 3, and 12 divided by 3 is 4. So we could also use that for our time, or we could even use 0.75. However, I think fractions are more exact, because sometimes in your rounding, you might round too much or too soon. So fractions, you cannot go wrong with them. So the answer to this is 90. And again, what we were talking about was how much interest will she have to pay for this loan, and that will be $90. Of course, she will have to pay the loan back, the $4,000, and then plus the interest. So this will be the total combined, but we will get to that in a minute. So for the next example, we have Bank of America issue a 10-year bond with a maturity date. This is when the loan expires, or the full term of a loan. Maturity date in 2022, and an annual simple rate interest of 5.7%. The interest is paid semi-annually. So Santiago buys a $10,000 bond. Determine the following. So the first question is, how much interest will Santiago earn every 6 months? And so let's define our variables or analyze our quantities. So what we're going to have here is, again, we're asking about the how much interest. So the question is how much interest, and what we have is the present value, 10,000, that is here, the price of the bond, and for the rate we have remember we got to divide by 100, so this will be 0.057, 2 units to the left. And here for the time, it is a little hidden there, but if you notice here it says semi-annually, so we're going to consider that 6 months. So this could be 6/12, or we could use 1/2, or we could even use 0.5. So with that said, we're going to use the interest formula, present value times the rate times the time, and we're going to substitute what we know, 10,000 times 0.057 times 1/2, and that will give us $285. Now the next question says, how much interest will he earn over the 10-year life of the bond? So now we're going to be changing our time. However, our other two variables will be the same. So the present value is still 10,000. The rate will be 0.057, and the time will be 1/2. So now we just have to, same formula, present value times rate times time, and so the interest will be 10,000 times 0.057, and now instead of 1/2, that should be a 10. So 10 years, for that is the full life of the bond, and that will give us 5,700. So that is the end of problem 2. So let's go ahead and see if we can finish the third one. So now here we have a new formula, and this is the future value. And so the future value, just like I was telling you on the first problem, if we wanted to know how much interest she had to pay back on example 1, was the present value plus the interest. And so that is what we're saying here, present value plus the interest, and so that will give us future value, and for that we use FB. So if we were to substitute this interest with the interest formula that we've been using from the previous 2 examples, it will be present value times R times T. Now if you notice, both quantities have the present value, so we could factor present value out. If we factor present value from here, we get 1, and if we factor present value from here, we get RT. And so that is the formula that you see here. So with this example, you see present value time parentheses 1 plus RT. So we have Hay borrows $20,000 from his parents at a 5.25% to add a room onto his house. He plans to repay the loan in 19 months with a bonus he expects to receive at that time. So that's why he borrowed the money. So the first part is to find the future value. How much is he going to pay at the end? So this will be present value times 1 plus RT. And so we have for present value 20,000, the amount of the loan. For T we have 9/12, or we may say 3/4. And for R we have 0.0525. So if we substitute everything in here, we will have 20,000 parentheses 1 plus, and here we're going to multiply the rate, which is 0.0525 parentheses open parentheses again, and then you will enter your 3 divided by 4 close parentheses. Then you have to close parentheses again because it will be this one here. So the answer to this question will be 20,787 with 50 cents. So that will be what Hay will have to pay his parents back, the 20,000 that he borrowed, plus the 787,000 with 50 cents that he accumulated in interest. Now, the next question is, and actually, I don't think I have that part here correctly. But no, actually, yes, it is here. So if we want to know, for example, what was the interest, we will just calculate future value minus present value. And so that will be what I just mentioned, 20,787 with 50 cents minus 787 with 50 cents. And so that will give us 20,000. Actually, no, this is wrong. We subtract the 20,000 because we're trying to find the interest. And so that will give us 787 with 50 cents. Now, if we were to do the same loan, actually a different amount of the loan, now for present value, we want that. And we are talking about 85 days. So that will be 85 over 365. And the rate, this is T, the rate will be 0.09. So if we substitute that into our formula, we will have 11,280 times 1 plus the rate 0.09 times 85 divided by 365, and that will give us 11,516 with 42 cents. And if we want to find the interest of that, it will be the future value minus the present value, with this one being the future value. And if we subtract the 11,280 from the 11,516, we will get 236 with 42 cents. And that concludes example number 3.